Hi, welcome to ESP8266 tutorial by Robojax. My name is Ahmad Shamshiri. I'm presenting this tutorial from Canada. In this tutorial, we're going to learn how we can turn on and off or control AC bulb, AC loads such as fan or bulb via relay from Wi-Fi using ESP8266. This is the NodeMCU. We can turn the lights on, turn it off, or using mobile device and D1 Mini to turn on and turn off, or using D1 Mini with external relay to turn on and off a light, or using mobile device with NodeMCU to turn on and turn off the light. You can get the code for this by clicking at the link below the video in the description, which will take you to robojax.com/learn/Arduino. Let's get started with this. And selecting type of relay for the NodeMCU ESP8266 and also the D1 Mini ESP8266 for both cases, because these modules both operate with 3.3 volts. USB gets 5 volts, but internal circuitry and the GPIO, the pins, are based on 3.3 volts logic. Majority of the relays that are available are 5 volts, but there are 3.3 volts relay available, not as much as this 5 volts that are, because they are popular with Arduino. I had three options for relays: either this type of relay which has two LEDs, this is also 5 volts relay, or this one, sometimes it's called keys relay. This doesn't have those large LED, and this is also 5 volts, or I could get this 5 volts shield, but this is only for D1 Mini, where you can insert this pins and the connector of USB on this side. You just insert it and it doesn't need any wiring and it will work fine, which I'm going to demonstrate that. But between these two, this has one type of driver for the relay. All these components are called a driver with a transistor, and also this one has different. Let me show you. So this is the one, the keys, and if this is the circuit. The schematic diagram, they have used NPN or negative transistor. The arrow is out, so the emitter is connected to the ground, and then the relay is between the collector and the 5 volts positive. For the base, this has not been properly biased because they put LED like this. This is not a proper design, but it just works fine because we always expect 3.3 volts or maybe higher. So this will work, but this can be triggered even with 1 volt up to 5 volts. So this can work in any situation. For that reason, this is suitable. But this one does not operate with 3.3 volts logic. It needs strictly 5 volts. And here is the schematic diagram for that. And the relay is between collector and ground, while the other one was between emitter and ground. So the configuration of this makes it not to be triggered with 3.3 volts logic. Only with 5 volts this will work. For that reason, we are not going to use this, and we are going to use this one, and also I'm going to demonstrate it configuring this as well. Now let me show you the wiring. First, this is my external 5 volt power supply for the relay, and I've connected it in here, the negative, and this yellow is the positive. To connect this relay, I'm connecting these two wires. The middle wire, the middle pin is a positive, this is a negative, and this side is the signal. Blue is my positive on this side. I'm connecting blue here to the yellow, which is a positive, and the other wire to the ground, and my relay is now powered. In order for this to operate, it needs a signal. I'm using this red wire to test it for you. And this input, I'm connecting it to the positive, which is the middle pin. If I connect it, you see the relay is clicking and turning on. This needs high to turn it on. If I connect it to the ground, nothing happens, and it means turn off. So when it's disconnected, it is as if this is off. For this NodeMCU, I'm connecting one wire to the ground and the ground must be shared with external power supply, otherwise this will not work. So make sure you have one ground to the ground. So here I'm connecting it to this point, to the ground. Now the NodeMCU is also connected to the ground. I'm connecting a black wire to pin 1 because this relay shield is connected to pin 1. I don't want to change the code, so when we run this one also will be connected to pin 1, or the NodeMCU, the larger one. So this is now to pin 1, and the other side, which is also female, will be connected here. Now the wiring is complete. Now the wiring is complete. I connect now my external, my USB, to turn this on. I can do so, or I can connect external 5 volts here from this 5 volts which I have, and then connect it to VN. This one has a VN pin. So when I connect it, now it gets 5 volts, and the circuit is running and the relay is ready. This is an AC desktop bulb, and this is a power plug that I connected to the wall, and 120 volts, which will turn on and off. Now at this point, I've cut one of these 2 wires at this point and twisted it and soldered it. Can be connected to relay. Job of relay is to connect this, and the AC bulb is on, or AC load, whatever fan you have, and disconnect it to turn it off. So I will be connecting these 2 to the relay. Here for my AC bulb, for this AC bulb, I'm connecting the 2 wires that I've just shown you to these 2 terminals of relay on that side. One on this side and the other on this side. Now this is the wiring for D1 Mini. The rest is exactly the same as I've just explained it, except from here we're connecting it to D1 at this point, and then the same way we have to connect ground. There is a ground here, the second pin from this side. So we have to connect it to the ground of breadboard. So we must have one ground there, and then the signal from D1 to this point. And this one also can be powered up from external power. I'm connecting this wire to 5 volts to this line. These are all 5 volts. If you want to learn about breadboard, I have a separate video. The link for the breadboard is in the description. So I'm connecting it to the last pin here, which is 5 volts. As you can see, already it turned on. I've modified this code from here. If you select generic ESP8266 module, then you will see from file, example, and scroll down until you see ESP8266 web server and then advanced web server. I've taken that code and modified it for this purpose because majority of the components are from there, and I've added these mapping because on the boards you will have D0, D1, D2, for example, up to D10, and they each refer to different pins, and these are confusing. So we will just use, for example, we are using D1, and D1 is printed on the board. So here we define integer relay pin D1, and then we define these text relay on, relay off as button title 1, button title 2. I'm referring it to the web page or the screen that we turn it on. This on and off, this is the text that's coming from there. After that, relay stat, that's the initial state of the relay. You can put it 1 or 0, whatever you put. The relay will be either on or off. And then these are the included file that were coming. Once you install the board, you don't need to worry, they're all included. And here I'm inserting my SSID for my router and the password. I'm not worried if you know it, because the router will be turned off once I finish the recording. You must pay attention to your SSID. If your SSID on your router has uppercase or lowercase, you must insert it exactly the same way, otherwise it will not work. So capital R is not the same as small r. And the rest I'm not going to change it. This is the HTML handle root. This is the page that I've created, which will display the page for you on the screen. If the relay is on, so we print one type with a different title, or different title 1 or title 2 if it is not. So all of this, and then the last line will print this HTML. So all the page is starting from here, and then we add more stuff. This means concatenate equal with something else, and then concatenate or add to HTML, this thing to HTML, or button to HTML. So we are stitching or adding more elements of page until the end with the body. I'm on the page. If I press on Chrome Control U, I will see the code. I have not formatted, so it takes less space. If I press Control plus, it will increase. This is the text that is behind the scene, which will print that. You see here, relay on, it says light on. So this is a div that is printing that button for us. And then you will see the body starts and end of body with /. So these are all the elements of the code, and this is the main one that is printing the link and printing the text light on or light off. So this HTML is the whole page, and we use it with server send with this code of 200 as a text and HTML, and we print this text in here. So this line is printing the details. Not found is the handle. Not found is the function that is taking care if a user requests something that is not available. For example, if I type here book /book, it will say URL book not found, because we have not defined it. We have defined only relay, and then for that purpose, so this is taking care of that with a message with a code 404. And inside the setup, we are defining relay pin as an output. This is the pin D1 we defined at the above, and then we initialize the relay at the initial state, digital write, relay pin on, 1 mean on and 0 mean off in this case. And then the serial monitor is initialized with 115,200. This is a value that is this one at the lower right corner. It must match, otherwise you will not be able to see this number. That's for debugging for my own purpose. And then these are for Wi-Fi. I have not changed it. I have not changed these. I have not changed these. And here I have defined this Robojax ESP8266 that you can access the page with. Let me see if it works. In some networks it might not work. You see it worked. So you can just type the text, whatever text you define, and put, but make sure that keep that in mind. If it doesn't work, you have to go with the IP address. And this was originally exactly the same. I have added this line here, server on /relay, which means if the user requests or enters /relay, and the type is get, then go and execute this function, which I'm going to explain. This is at the bottom of the code. These are exactly the same. I did not change it. And this is where the page is updated. Server handle client, and this is taking care of the, and then multicast DNS. DNS means domain name system. So this is updating that ESP8266 from Robojax. So this is for that. And here is the main thing that we do. We say if relay state is true, this means true, or I could put equal 1, which is access. Automatically it means if it is 1 or it is true, then do this, meaning digital write relay pin low. Else, which means if it is equal 0, do this, which means digital write relay pin, it goes to pin 1 and sets it as high. And this is just printing that 1 that you saw on the serial monitor. This one is coming, it's telling us the current state. And if I change it from here, let's see, it has changed to 0. So that is for debugging. I was working, so I can comment this out. And we give it a few hundred milliseconds. This was 500, it's too long because I was printing the text, so make sure to make it 100. And this is relay control, where when you touch or click, this will take action. So here it says if server argument do is equal on. If you pay attention here, it says do equal off, and if I click it again, do equal on here. Is on, we set relay state equal 1, else relay stat equals 0. That's it. So this is just updating the variable, and we also make sure the root handle is executed at the end. Nothing else. So when the loop runs, it checks this value. If it is high or low, it takes appropriate action, either this or this, which will turn on or off the relay, and as a result will turn on and off the light or AC or DC load that you have connected to the relay. And now I'm opening the serial monitor for NodeMCU, bringing it on this side. And now carefully, because this has AC at this point, I've just pressed this push button. And it shows that 192.168.1.100, and press enter. And here I got the screen. Now I'm pressing Control and plus, so I can increase the text. And now I'm clicking. Pay attention here, this light will turn on for this module, and you will see this light. And then if I click off, it perfectly responds. Now the device is connected through the external power. AC bulb is also connected. Everything is ready. Let me turn it on. And as you can see, it turns on, and turn it off. And the text is changing. The color is also changing on the screen, so you know green mean go or turn on, and then red mean turn it off. If you're just using USB and not external power, this 5 volts just disconnected. Connect your USB, connected, to show you that in both cases it just works fine. And clicking again. Now let me demonstrate it with NodeMCU and using my mobile phone. I can turn on, turn off. Now let me demonstrate it with D1 Mini. Relay is connected, external power is also connected, AC power is connected. I have connected my phone to the 192.168.1.101, and as you can see, I can turn on and turn off. There is a lagging on the delay on the screen, but the light is responding very quickly, and it works without any issue. If you got any issue, just press this reset button and give it a little time. It will reboot. Now let me demonstrate it using my mobile device. The first thing we have to do is to be in the same Wi-Fi that as ESP8266. That is connected to Robojax. This is also connected to Robojax. I just typed Robojax ESP8266. Let's see if it works with my phone. As you can see, it didn't work. .1.101, and it is now ready, so I can turn on. It took a while, and turn off. The first time it takes a little longer, and then it responds very well. Thank you for watching. This was how to control an AC bulb or load or DC load using ESP8266. If you like this video and learned something, please thumb up, as this will help my video in the search algorithm of YouTube. If you have comment or question, post it at the comment section below. I try to answer and reply. If you want to get updates of my upcoming videos, make sure to subscribe. Insert the relay for D1 Mini module. If you have this shield, the relay shield, you will see that it says Y. You will see here 3.